Everyone, welcome to another exciting moment. This time we're going to look at modality of a solution. Now we have a calculation that will help us understand how to really take care of a modality question that has to do with normality of solution. Now in this case, the question says in the following reaction, calculate and find the normality when it is 2 mole or 2 moles tetrazoles of a 6-acid or sulfuric acid. If you look at this now, you find out that the reaction from this chemical reaction, looking at the this balanced chemical equation here, this chemical reaction is showing us what the relation that is between them. So in this case now, if you look at this, you find out that the equivalent for this the the equivalent or ions, hydroxide ion here that is required to neutralize the acid is two ions of hydroxide hydrogen ion there, hydroxide ion there that will neutralize the hydrogen ion there. So in that case, that means our equivalent, it means that our equivalent is what? 2. And then the molarity is already given to us. Molarity is given to us, which is 2 mole. And we know that normality is equal to molarity. Molarity times what? Equivalent. Times equivalent. So our equivalent there is what? Molarity is 2 times equivalent. We will have normality is then 4. So that's this thing. And then we're going to look at another question and see how we can explain more in this question. Okay, let's look at. Now the next question here states calculate the normality of the solution obtained by dissolving 0.45 grams of potassium carbonate in 300 cm cube of water. Now assuming that the salt solution is reacting with acid. So if it's reacting with an acid, what it means here is that then we can look at the chemical equation of the salt and the acid, the salt and the acid. So in this case, what we have here is, from this chemical equation, so from the chemical equation, we find out that the hydrogen ion there is 2. The reaction now from here, we'll be able to find out that the ion that's required here is 2. So this ion, the 2 ions, electrons that's required there based on the reaction, make up the equivalent. That means it means that the equivalent of this reaction, the equivalent is equal to 2. And then another thing we have here that is given to us is grams. The gram of the potassium carbonate, mass of potassium carbonate, we have 0.75 grams. The molar mass is already given. And the next thing we're going to do now is to calculate, to find the amount of potassium carbonate, the amount of potassium carbonate. Amount of potassium carbonate will then be 0.45 over. That will give us 0.003 3 moles. So the molar concentration or molality, the molar concentration or molality will then be 0.0033 all over 0.3. So in this case now 0.3. All right, to give us, okay, what we have here is 0 points. When we divide it, we'll have it will give us 0.011 mole. That is mole per dm cube or per liter, per dm cube, or perhaps say or per liter, 0.011 mole per liter. So now we have the molality. We also know that to calculate this molality, to calculate the normality now, as we have done before, since you know that normality is always equal to molality times equivalent. Molality times equivalent. Now the equivalent of this is what? Molality is 0.011. Then the equivalent is 2. That will give us 2 multiplying this. We have 0.022 normality. All right, thank you so much. I will want to read your comments, like and share. Thank you so much. And also don't forget to subscribe.